video. What's the difference between y equals x squared like that and y is less than x squared? Well, there's shading involved. I wish it was just that simple. Okay, today is not quite just that simple, but do you get that this has only the spots that are on the equation, and this has all the spots that are under the equation? So like this spot here, it works. 2, 1, which is that spot. If you put in x is 2 and y is 1, it'll make a true statement. If I put a 1 there and a 2 there, 2 squared and 1 on the left side, 1 is less than 2 squared. Cool? That makes sense? Okay, what about this spot right here? It's not in the answer set. So 1, 2. If I put the 1 here and the 2 there, 1 is not less than 1 squared. See how 2 is not less than 1 squared? That doesn't work. Okay? All right, so now let's get back to what are we going to actually have to do today? Well, first, let's remember what you did yesterday. 2-second little reminder. What if I had to, I promise you this one won't factor. Okay, if it won't factor, how the heck could you ever find the roots, the zeros, the x-intercepts? Just taught you yesterday. It wasn't just factoring yesterday, it was, yes, quadratic formula. So don't even solve it, but would you please stick all the numbers into the quadratic formula? Your f of x would be here, and then it equals that. So x equals negative b, in this case negative 3, plus or minus the square root, and just stick all the numbers in. Don't simplify it, that takes too long. B squared is 9. Minus 4 times negative 7 all over 2 times 4. Do you get how I got negative 3 plus and minus a whole bunch of stuff all over 8? You with me? That's how you get the x-intercepts. Now, what if for today this was set less than 0? Well, here's what you do. Would you agree this is a right side up parabola? You with me there? Do you agree it has a y-intercept, which is when you set x equal to 0, of negative 7 is the y-intercept? Okay, so then I could go over here and sketch it quick, and I could go, well, the y-intercept's negative 7. It's a right side up parabola, but I can't tell which side the vertex is on, so I can't tell if it's that or maybe it's that. How would I be able to tell? Use one of those little formulas we haven't used yet that I taught you yesterday. Not the quadratic formula. Yes?
Would you change it to vertex 1?
Nope, but that's a good idea. That would have worked, but there's a much faster way. It's
the negative b over 2a.
Yes, and do you see it right here? There's the negative b over 2a. Do you get that that's negative 3/8? Do you get that means it's on this side? Huh? That makes sense? It's the blue one. It's not the black one. It's the blue one. Okay, so there. Now I know that that's what my parabola kind of looks like. If I want it to be, where is the parabola less than 0? If you like this better, you might think of this as y equals 0, because y equals this whole other equation. Then you're saying, when is the parabola less than this kind of 0? When is it less than the green line? Well, between here and here. So do you get those x-intercepts are important? And that's what the quadratic formula gives you, is the x-intercepts. And our answer is a range of answers. Anytime you have a less than, you have a range of answers. Would you agree that if I said x minus 4 is less than 5, the answer isn't just one thing? Let's do it. Plus 4, plus 4. What is the answer? X is less than 9. It's a whole bunch of things. Like 8, 7, 6, 5, 4, 3. Do you get what I mean? The answer is a whole bunch of things because it says less than. So I want you to get used to this pattern that whenever you see a less than sign, you're going to give a number line and you'll answer on the number line. And you'll know that it's a whole range of answers. In this case, x is less than 9. In the quadratic case, right here, when was the parabola less than the green 0 line? In here. So if I only knew my x-intercepts, it's a number line with these two x-intercepts, whatever they were, and then I got a shade in between them. So then it's just use the quadratic formula to find this, and then that would have been it. Okay, so that was a quick reminder of stuff I taught you yesterday. Now a 2-second, we gotta wait, reminder of the stuff that I taught you the day before that. Y equals x squared plus 7x. What if I only wanted to know between 1 and 4? We usually put brackets on this to show it's not a point. In the interval from 1 to 4, what is the slope? While you work on that, I'm going to answer this other question. Go ahead.
I was wondering for a second ago, isn't it like it's on y equals 0?
That's an excellent question. See how we have a not or a less than? If it's just less than, then it won't be a filled in spot. It'll be an empty spot. So if that's what you're talking about, you're right. I wasn't trying to get the final answer because I left it blank here, but you're right. They'd be empty circles. Okay, so back to this. Do you remember that this is the kind where you have an XY chart and I just gave you X was 1 and I gave you X was 4 and you had to figure out the Y's? Know what I'm talking about? If you take the 1 and you stick it in the equation, you'd get y equals 1 plus 7, which is 8. To get how 1 comma 8 was a point. And then you'd find the other point and then you'd find the slope. All right, there's a quick brush up on this chapter so far. Now, you should be able to answer all of these by either using, one more thing I didn't mention is complete the square. It's awesome. If you know how to complete the square, I'd do it on number 1 to answer the vertex question. If you'd rather, you could just use negative b over 2a, but it's slow. Complete the square is fast if you know what you're doing. All right, try to answer this, which is really 3 questions because there's 2 questions in number 1 and then there's this question too. All right, I'll pause for a minute while you try to answer those and see if you've got A-level understanding on the beginning of the chapter. So here we go. If I were going to find the vertex, I would complete the square. And I know I'm biased, I'm a math teacher, but I also know what you need to know for your test. So let's practice completing the square, even if you didn't do it before. I'm going to put the plus 5 over there so I have room to work. And then I'm going to go half of 6 is 3. 3 squared is 9. Then a minus 9. And then this part can be factored. X squared plus, or wait a minute, sorry. X plus 3 quantity squared. And that part's minus 4. Vertex is at negative 3 comma negative 4. Raise your hand if you had the vertex right. Okay, good. Next, what if I want to find the x-intercepts? Well, a quadratic formula does work, but if you can factor it, you should. X plus 1, x plus 5 gives me really quick x equals negative 1 and x equals negative 5. And those are the x-intercepts. And then down here, average rate of change, you go x, y chart. I reminded you that these are things that are not a point. It's an x value to an x value. And when you put in 1, I think I remember it's like 22, and I don't remember. Jack Knudsen, do you remember? What are these? Have you found them yet or not?
No,
Okay.
did the first one.
All right, I'll walk you through it. So we're going to figure out when we stick 1 into this equation here, what we get. So walk me through it. 1 minus 1 plus 4. 4. And then stick 3 in. Tell me what you get. 3 to the third. Go ahead. I think I heard you say 27, didn't you?
27 minus
Say it out loud. Minus 9
plus 4.
plus 4. Okay, good. And 27 minus 9. 18 plus 4. 22. There's where the 22 came in. And now finish it. the whole point was to find the average rate of change, which is like slope.
So 22 minus 4 out of 3 minus 4.
Nice. And then can you simplify that and get the final answer? 9. Raise your hand if you had 9. Okay, good. All right. Any questions about that? Okay, that's like the whole beginning of the chapter. Milan, you got a question?
Yeah, this is more of like a verification.
Yep.
So when you're doing the plus 9 and minus 9 on the first question, you get that by taking half of 6, right? And then
Yep.
square.
Half of 6 and then squaring it.
And
We
then you
call
can
it half
square
and
it.
squared. This will always match this then.
And then you just put half of this.
Half the 6 was 3. 3 squared was 9.
But when you do x plus 3, is that just factoring that?
That's just factoring this part right here. That part factors to x plus 3 and x plus 3. Make sense? All right. Thanks for asking. So this looks a little bit like what you did on that little quiz that we took yesterday, which turned out we don't have time to grade today because today is pretty intense. So we will grade that a different day. I want to rewrite this like this. And I want you to just see if you get the subtle difference between what I have and what they had. I encourage you to do that too. You see it? Yes, sir.
The thing you were just talking about, the gradient, that's not, is that summative?
It is formative.
Okay, it's in the summative.
I think if you refresh, you'll see it's in the formative. All right. So this, I need to start by subtracting 4, and then I'm going to divide by -3, and go ahead, solve it, everybody. I'm going to pause for a second while you solve this. And I know you're like, but I don't know how to do the less than. Just get it to that part first. Right there. Do you get it to this far? Now, what did I just do wrong? Classic mistake. Davis.
You forgot to flip the sign.
Yup.
Divided by a negative.
Because I divided by a negative, that should be a less than 2. Okay. Now, pay attention on this part because I actually teach this differently than some of my colleagues do. And I think it's better, but you have to decide for yourself. 2x plus 1, and they just say change it to an equals. And I think it's better to leave it as a less than 2. Now the reason is because this next part freaks people out, and so other teachers don't want to do that. They just want you to test intervals, and I think this is kind of cool. The other part I write is 2x plus 1, and then when this, you all know that this is going to change from 2 to -2, right? But then what do you think should happen? Well, since I made such a big deal about that sign, obviously it must have to do with the sign flipping. So if you can't get why we should change the sign, the only explanation I can give you is, isn't it kind of like I multiplied by -1? And then that switches the sign. Now, if that blows your mind too much, then just make them equal signs and solve them. You're going to get the same 2 answers. But the way I showed you, you're going to know which way to shade from those 2 answers. Either way, we should get the 2 answers. Again, if you just want to make them equal signs instead of less thans and greater thans, that's fine. So again, me and the other teachers would agree that -3/2 and 1/2 are the 2 key spots, and that since it says less than in the problem, the original, or greater than in the original problem, and then it's switched. These are not filled in circles because it's not or equal to. So these are empty circles. And then I get to know where to shade. Because I stuck with the signs here, I get to know to shade less than this and greater than that. And so I get to know to shade in between. What would the teachers do that just use equal signs there? What they tell the kids they have to do is test an interval. So what's between -3/2 and 1/2? 0 is. And you test the interval by going up and sticking in a 0 in the original problem. Let's see what happens. 0, 2 times 0 is 0. 0 plus 1 is 1. Absolute value of 1 is 1. So now I have 4 minus 3 times 1, which is just 3, greater than -2. And this part's a pain in the butt, so I'd rather avoid it. 4 minus 3 is -1. No, it's 1. And then it's saying 1 is greater than -2, and it is. So then you can shade that area. But I already knew that. So I like this way of doing it with this. But you're going to eventually need to know how to test intervals anyways, because on quadratics, you can't bring the signs down. You'll see why in a second. But for absolute values, you can bring the signs down and flip one around, and it works really slick. Yes?
How would you know to like only shade in the middle and not shade like the whole thing? Didn't ask the intersect?
Okay, you can assume that it is asking for the intersect of the two. All right, so one more test, because again, this testing intervals part is the part that makes this one of the top 10 most missed questions on tests in the first semester, is because kids are not good at this. Would you please just test yourself by sticking, actually what's easier than 2 that's above a half? 1. Stick 1 into the equation and verify that it doesn't work. What by work I mean, does it have the right sign in it? Stick 1 in and verify it should not work. It should not be greater than. Did you get -5 is greater than -2? And I know these can be confusing even because you got negatives and what's bigger and when in negative land. Well, if you think of this on a number line, here's where -2 is, here's where, nope, here's where -2 is, and here's where -5 is, and things that are further to the right are bigger. So that's supposed to be bigger, but it's got the wrong sign. And that's the whole point, is that when we tested one, it did not work. Look, we didn't want it to work. We didn't think it was supposed to work. We tested it, it verified it does not work. That's called testing intervals, one of the toughest things. We'll do more of it in just a second. Anna,
Show that -5.
say that again.
Can you show how you got -5?
Sure, when I put 1 in, so I'm going back up here and I put in 1. What's that make? Plus 1, absolute value 3. 3 times -3. 4 minus 9. Got it? And the other side was -2 because it just was -2. And there you go. And it is hard to tell if this is bigger or not, so I made my number line up here just to show you that bigger numbers are to the right. The further you go to the right, the bigger numbers are there. So this one's bigger. So this statement was false. Yes?
When you were solving for the original two inequalities you got,
Yep.
did you flip the -1.5 twice? 'Cause you did it in
Just hold on.
direction as
Hold on. Hold on.
1/2.
Hold on. All right. So here's my -3/2. You'll note that I didn't flip that because I didn't divide both sides by 2. It is correct.
But you did. At the bottom, you divided by 2.
I divided by 2. I didn't divide by a negative.
Oh, okay.
Here, I'll show you. I'll put in the step. Divide by 2. Divide by 2. See, I didn't divide by a negative, so I don't want to switch the sign. So I did do that one correctly. I make plenty of mistakes, though. I'm glad you asked, because The odds are pretty good that if you think there's a mistake, that there might be. All right, any other questions? Okay, then this little trick I just taught you about switching the signs was right there. We had to switch the sign to backwards from what it was. That's really helpful because you know which way to shade. Headphone. Thank you. Probably wasn't even anything on there, but all right. Now this kind, the sad part is you can't bring the signs down, so you can't use that little trick. All right, so one thing at a time. What do you do? Well, first of all, I want you to think about these functions as f of x equals, let's say it's a quadratic like most of them are. Why do we want things equal to 0? Because see, these aren't, and we're going to have to fix them. And you're going to be wondering, why would I want to set it equal to 0 on one of the sides? I'll show you why. Because if you set your function equal to 0, what you're really saying is you got the y value right here, right? And what happens if you set y equal to 0? You are finding the x-intercepts. That's what we're trying to find. That's why we want it equal to 0. See? All your quadratics should be set equal to 0 if you're going to use a quadratic formula, or if you're going to factor it, they have to be set equal to 0. Because then you'll be finding the x-intercepts. Okay, so back up here. Let's get this set equal to 0. I want everybody to take away 3 from both sides, but let's do a double step because I like dubstep. Bad joke. There, I'm double stepping because it'll just save me some room. And now I got 2x squared plus x minus 3 is less than or equal to 0. And once again, it factors. And if you can factor it, you should. But the problem is you can't use that less than sign. Doesn't work with parabolas. It'd be awesome if you could just say this is less than 0 and that's less than 0. It doesn't work. They're equal to 0. They're not less than 0. They're equal only. So this is 2x and x, and the best and brightest factoring students already have it. If you've got it, would you say it? 2x what? Plus 3, and then what? All right, I'm going to double check you, and that does work. Very good. So just scribble this problem out. We don't want it distracting us. And then I got two answers. X equals negative 3/2, and x equals 1. And it's so tempting to write there, just think you're done. But this is a less than sign, which means that you have a whole range of answers between these or outside of these. So here's what you do. You make your number line, and everybody, from my experience, gets this far. And they get this as 1, and they get this as negative 3/2. Everybody's an exaggeration, of course, but the vast majority of kids will identify those two as the roots. And here's where they start screwing up. Either they fill them in when they shouldn't, or they shade in the wrong spots. That's what makes this a top 10 most missed question in the whole first semester. And if that's saying a lot, actually, because there's about 13 questions on our typical tests, and there's 9 tests in the first semester. So that's like over 100 questions. This will be in the top 10 most missed out of all test questions, because people have a hard time shading in the right spots. Yes?
Why wouldn't it be filled in if it's less than or equal?
Oh, I haven't filled them in yet, because I'm just saying you have to figure that out. Okay, so now you have to figure out, do I fill them in or not? And do I fill in both of them, or do I only fill in one of them? And then do I shade in between them, or do I shade outside of them? And hint, it's all about testing a number. Like test 1 itself. Try sticking 1 in the equation and see if it gives you a less than like it's supposed to. Just try putting 1 in. Two is less than or equal to 2. Is that a true statement? 2 is less than or equal to 2. Yeah, that's true. So 1 seemed to work. It could have filled it in. How could I have known I could fill it in without even having to test it, Nicole? Yes, since there's an or equal, do you guys know that less than or equals always get like included in the answer? They're or equal, so they use a bracket on those, or in this case, fill in the circle. And then the same goes with the other end. I'm not even going to waste time and test that. That works too. But now the hard part. Do I shade in between those two dots? Or do I shade outside of those two dots? And I know you can test intervals, but I want to show you an even better way. Because kids have so much trouble with this, I want you to have two different ways of doing it. Would you agree that this thing is a right side up parabola? I'm going to recircle it down here. Would you agree there's no negative in the front, so it's a right side up parabola? And I want to know, where's the right side up less than 0? It's a right side up parabola. Look at this black parabola going in here. Where is it less than? This green line would be like 0. In between the two dots is where it's less than 0. So you shade in between them. Now, if that didn't work for you, because you're like, I don't get what you just said, then just test 0 and see if it works. 0 goes in here. 0 goes in here. And you get 0 is less than or equal to 3. True? Yeah, so it works. Okay, so if you just want to test the intervals, that's fine. When I tested 0, it worked. Like I said, the hardest question on this test and the top 10 of the entire semester is testing the intervals. Would you please test 2 and negative 1? Test 2 by sticking it in the equation. Test 2 and negative 1 and see if they really don't work. We don't expect them to work, but double check. You got to get good at testing intervals. Okay.
Negative 1 is within negative 3 halves and 1.
Oh, thank you. Okay, testing negative 1 would only be in the same interval here. So don't bother testing negative 1, my bad. Test negative 2 and 2. Good catch. I'll pause for a second while you test 2 and negative 2 in this equation. Okay, here's me testing 2. I'm going to take this equation. I'm going to stick 2 in my head. Yes. And that's 4 is less than or equal to 1. 4 isn't less than 1. That didn't work. And if I stick in negative 2, I'll have 4 is less than 3 minus negative 2. Uh-oh, wait a minute. My head's hurting.
You forgot to do 2 times 4.
Ah, okay. Thank you. So I'm sticking in 2, and I got lucky. 2 squared is 4 times 2 is 8 is less than or equal to 3 minus 2 is 5. All right, what's going on? Putting in 2, and it's working, and that's freaking me out. No, 8 isn't less than 5. Okay, sorry. It's not working like I expected. Cool. I tested 2. It didn't work. Now I'm going to test negative 2. And negative 2 squared is 4 times 2 is still 8. But a negative 2 going in here should give us 3 minus negative, which is plus 2. So, so many mistakes, but I apologize. But bottom line, 8 isn't less than 5, and 8 isn't less than 3 minus 2 is 1. And so those are the two statements you'd have checked, and they didn't either one of them work. And I can see, I mean, I'm saying the kids have a hard time testing. I have a hard time testing the intervals right. But yeah, I verified those didn't work. It only worked on the inside. And so my final answer is from negative 3 halves to 1. And it works on both of those. There we go. Those are hard. Don't say I didn't warn you. So let's go to the homework. And this is just the same exact thing. And it's telling you to find the critical numbers, which are the zeros, and put those on a number line and make your test intervals. Then stick numbers in from your intervals. And then see if it's true or not and whether or not to shade there. And be careful with the boundary values. like if it's less than or equal, and then you're gonna, you use a filled in circle. And if it's less than or greater than, then don't include them, meaning it's an empty circle. And I covered all those topics. Just thought I'd show them to you again. All right, here's the homework, and we're going to skip number 30. But I think you should do the first 3 there. And then, in the spirit of trying to keep it doable, just do this one, because it's a lot like your lab you're going to do, where we go throw up a tennis ball, and it makes a parabola. Okay, so I strongly recommend 36. It's not exactly the same as the tennis ball lab, but it has some of the same ideas. The rocket's only in the air between time 0 and time 20. Does that make sense to you? The rocket is upside down, or the parabola is upside down because there's a negative in front. They rounded the gravitational, which would normally be negative 4.9. They rounded it to negative 5 to just make the equation easier. When is it 250 feet off the ground? That's a line that goes like this at 250. Do you get it's very likely that it'll go past 250 on the way up and then on the way back down again and go past 250 again? And a parabola having 2 answers? Madness. All right, that's the setup one. And on this one, I decided that there is something similar to this, so this is worthy, but skip these and this. Just that 3A. All right. You gotta admit, I cut the assignments way back. The question is, are you doing what I am assigning? And I know I can't tell. I really can't.
More page.
So you can skip the last page. Last page is a complete review of absolute values, which I think you've got down. Okay. So that's it. That's all I got for the video for today. Saving.